Dal punto di vista della sicurezza antincendio, l'aspetto più importante da considerare è quello che dobbiamo garantire la sicurezza. La sicurezza antincendio richiede, pretende, a ragione, che in caso di incendio si riescano a salvare la vita delle persone e eventualmente anche il resto che si vuole mettere in salvo. E questo è l'obiettivo principale. Il fatto che si abbia a che fare con un materiale che ha caratteristiche più o meno particolari in caso di incendio è un aspetto da considerare, ma non è l'aspetto essenziale. Il fatto che il legno brucia non è l'aspetto da considerare per primo. La prima domanda da farsi è: qual è l'effetto del fatto che il legno brucia sulla sicurezza antincendio? E per fare questo dobbiamo chiederci cosa succede quando il legno brucia. Le strutture in legno dei nostri edifici sono tutte piuttosto grosse, piuttosto massicce. In caso di incendio il legno comincia a bruciare se lo lasciamo senza nessuna protezione particolare, però prima che il legno perda le sue caratteristiche meccaniche deve passare del tempo, e questo tempo è quello che ci dà quel margine di sicurezza per cui chi deve essere posto in salvo può essere messo in salvo, chi deve uscire dall'edificio può uscire e eventualmente possono arrivare i vigili del fuoco o comunque le opere di soccorso. E questo lasso di tempo è l'aspetto essenziale per definire la sicurezza antincendio.
From the fire safety point of view, the most important, let's say, issues in buildings, or let's say the most important things we have to consider are we have to delay the actual start of the fire, that's one thing, and we have to prevent the spread of fire from the location where it happened to other parts of the building. So this is very important. And if we're building with wood, we pretty much have different ways of how we go about those things. So wood itself reacts to fire, it burns, so in a way it actually gives more energy to the fire, technically. But it burns in a very controlled, slow, predictable manner. That means it's actually very resistant to fire. On the other hand, wood catches fire, but then it burns very slowly and very controllably. So wood, let's say soft woods like spruce and pine, burn with a rate of about 0.7 millimeters per minute. The wood that's going to be behind that is going to be completely intact, it's going to have full load carrying capability. So despite the fact it's going to be burning on one side, we're going to have a completely stable and safe structure on the other side, and the temperature on the other side of the wall or floor or plate, whatever, is not going to be rising by much or just marginally.
We look basically at how the load carrying capacity of the structure develops as a function of time and temperature. So we know in the case of fire that the temperature goes up from, and basically within 10 minutes it can go up to 800, 900, even 1000 degrees. Now, what we look at in concrete, in steel and in wood, how does the load carrying capacity develop when the temperature is so high? And in steel, generally we know that it becomes weak at 250, 350 degrees. It becomes weaker, so it loses a little bit of the load carrying capacity. In wood, however, it works a little bit different. We have a front of carbonization inside our walls, our floors. And this front of carbonization is slowly progressing over time. But it also means that what is after the carbonization layer, basically we have sound wood, we have sound material. So that material still has a load carrying capacity. And that means that we can predict with a very high accuracy what is the load capacity after 30 minutes of fire. So we can actually predict how long the building will stand up in a fire case. And that also means that we can predict how much time people have to escape from a building and how much time the fire brigade has to go into the building and save lives, because that's the main issue in fire safety design. And we have done component tests, but we have also done some tests on full buildings. Actually, one of the tests that has been done was done here in Trentino, so in the Arco Alpino. Basically what we did, we built a house of 3 stories, and we just set one of the rooms on fire, with, of course, the simulation of the furniture in there, etc. And there we actually can see that the structure is extremely fire safe, because the fire is not progressing outside of the room which we have set to fire. So even after an hour, the structure is basically perfect except for the room where we had the fire. Now, from those tests, we have learned how to design buildings and also how to design multi-story buildings, because there it's of course extremely important that we have a fire resistance of 60 or 90 minutes.
There are basically two different strategies when it comes to timber. You either protect it with additional layers, additional, let's say, fireproof layers, so either gypsum fiber and gypsum plasterboards, or you have thick enough cross sections that they can protect themselves. So, for example, if we build with light timber frame where the cross sections are smaller, we need to protect them with cladding, because when those cross sections would start to char, there would not be enough of the core left to support the load of the building. If we have massive cross sections, like bigger glulam cross sections or CLT, we have enough of the material that we can form this layer of charred layer around the elements, which in turn is going to protect the elements themselves. The most important differences between wood, steel and concrete are their differences in how they react to fire and also how they resist fire. Wood, I guess, in people's minds is problematic when it comes to fire because it burns. That is true, but it burns very slowly, very controllably. It protects a self-protecting char layer around the cross sections and leaves the inner core of those timber elements intact. And that core can then support the rest of the building without any problems. On the other hand, let's say steel, which is not going to burn, has a problem when the temperatures get too high. If you heat the steel up to 600 or 800 degrees, it's going to lose pretty much all of its structural properties. So it's not going to be able to support the building anymore. So it's not going to burn, but everything else in that compartment is going to burn, get up the temperature, and in turn cause that steel to potentially fail. So it needs additional coatings, additional layers to protect it. Concrete, on the other hand, is both doesn't burn and also sustains temperature quite well. The problem with reinforced concrete is that we need sufficient covers of the steel reinforcement that's in the concrete, because when that cover gets blown off, and it's usually in a quite explosive manner, it exposes the steel reinforcement, and then we're back to the problems of steel we had before. So when the heat gets high enough, the reinforcement is not going to be able to support it's not going to be able to perform its role in the load-bearing system, and the whole construction is going to fail again. With wood, wood's going to be burning all the time, but it's going to be burning slowly, controllably, up to the point where there's just no more material. But at that point, we have evacuated either the building or the fire brigade has come or so on.
Perché il legno è prevedibile anche in caso di incendio.
Wood is safe.